Okay, so we're finishing 6.1 from yesterday. So we should be on example 3. And example 3 is a system that is 8x minus 2y equals 7, and 2x plus y equals 4. So make sure you write that down. Now, if you guys turn back to the first page of your notes and look at our steps, the first step was to isolate one variable in one of the equations. Now, so far, that has been done for us every single time. Looking back and now to example 3, do we have any variables already isolated? No. I have x and y on the same side on the first one, and x and y on the same side on the second equation. So let's look at our two equations. Do any of the variables stick out to you that might be really, really easy to isolate one of them? The y in which one, the first or the second? The second. Why would that one be easier? Because the y is already by itself, right? So we did this in Unit 1. How can I get the y isolated by itself? Subtract 2x. So subtract 2x from both sides, and then I'm going to rewrite that equation. It's going to be y equals negative 2x plus 4. These two equations, 2x plus y equals 4 and y equals negative 2x plus 4, are actually the exact same thing. But now I have y isolated. So we can take that 2x plus 4 and plug it back in to y in the first equation. This is what we did yesterday, right? So we're going to get what? 8x minus 2y, but we know now that y is equal to negative 2x plus 4. So instead of y, I'm going to write negative 2x plus 4 equals 7. Here's what I want you guys to do right now. With your group, solve for x. Let's see, who can give me the first step in solving for x? Jordan. Good. Distribute the negative 2. Remember that sign is attached to it. So I always circle it and then draw my arrow to show my distributing. So that's going to give me 8x. What's negative 2 times negative 2x, guys? Positive 4x. And negative 2 times positive 4 gives me negative 8 equals 7. Okay, somebody from a different group, what would my next step be? Brittany. Adding, okay, we can add 8 to both sides. I see one thing that I would maybe be better to do first.
Combine.
Yeah, combine like terms. You want to combine like terms first because that'll make your steps shorter. So 8x plus 4x, guys, what does that give me? 8x plus 4x. 12x. Minus 8 equals 7. And now, Brittany, this is when I would add 8 to both sides. So you were right. We just want to do it in a different order. So that gives me 12x equals what, guys? 15. And then what would you do? Divide by 12. So we would get x equals 15 over 12. Can that be reduced at all? What goes into both 15 and 12? 3. So 3 goes into 15 5 times, and 3 goes into 12 4 times. So we have x equals 5 over 4. Are we done? No. How many variables were in my system? 2, x and y. And how many did we find just now? One of them. So how would I find, now knowing what x is, how would I find y? Plug it in. I would suggest that you guys plug it in to this equation right here. Does anybody have an idea why I would suggest that? Okay, can you say it a little louder? Yeah, because y is already by itself. So we just have to plug x in and simplify. So that's going to give me y equals negative 2x. What did we figure out x was? 5 over 4 plus 4. So y equals negative 2 times 5 over 4. What's that going to give me? Negative 2 is the same as negative 2 over 1. And when we're multiplying, what do we get?
10 over 4.
10 over 4. Positive or negative? Negative. Plus 4. Can 10 over 4 be reduced? Yes, by what?
2.
2. So that's going to be negative 5 over 2 plus 4. And what do I need to do in order to add negative 5 over 2 and 4? Put a 1 under 4 and multiply by what? What would my common denominator be? 2. So this is going to be, I'm running out of room here, y equals negative 5 over 2 plus what, guys? 8 over 2. And what's negative 5 over 2 plus 8 over 2? Positive 3 over 2. So we ended up with x equals 5 over 4, y equals 3 over 2. Sometimes you get fractions as your answer. They're all the same, but sometimes you get fractions. Alright guys, example 4. We have y equals negative 3x minus 6 and y equals x minus 4. Do we have variables isolated in this equation or this system? Yeah, actually, y is isolated how many times? In both of them. So we can pick which one we want to substitute. I always substitute the smaller one. So put parentheses around x plus or x minus 4. And what am I going to substitute x minus 4 into? The first equation for what variable? What's it equal to? Y. So right here, right? So what would my new equation be? X minus 4 equals negative 3x minus 6. So I'm going to have you guys solve it by yourself again. Here's what you need to do. Get all the x's on one side and all the numbers on the other side. Go. Okay, ladies and gentlemen, what would you do first? Any suggestions? Tatiana.
3x.
Add 3x to both sides. Good. We add 3x because negative 3x plus 3x gives me 0. So what's x plus 3x, guys? 4x. So this is 4x minus 4 equals negative 6. And then what would you do? Somebody from this group. Add 4. So this gives me 4x equals negative 6 plus 4 gives me negative 2. And then the last step, everybody? Divide by 4. So we get another fraction. So this time we get x equals, how does negative 2 over 4 reduce? Negative 1/2. Okay, thumbs up if you got that. Negative 1/2. This group, excellent. This group, excellent. Excellent. Okay, so what would I do next, guys? I found x. How would I find y? Plug it in. Who wants to plug it into the first equation? Who wants to plug it in the second? I would go with the second because it's way shorter. So we have y equals negative 1/2 minus 4. And I can't subtract these because we don't have what? Common denominators. What would my common denominator be? 2. So multiply everything by 2. And that gives me y equals negative 1/2 minus 8 over 2. Which gives me y equals what, guys? Negative 9 over 2. So how would I write this as an ordered pair? Perfect. All right, so example 5. This time we have fractions already in the system of equations. So we have 1/2 x plus 3 over 2y equals 5, and 2/3 x minus 1/3 y equals 9. I really don't like that there are fractions in this problem. So let's make it a little bit easier on ourselves. If you have fractions in your problem, we can cancel out the denominators, and then we'll only have whole numbers. So look at your first equation. 1/2 x plus 3 over 2x plus, or equals, or 3 over 2y equals 5. What's the denominator? 2. So here's what we're going to do. You are going to multiply the entire equation, just the first one, by 2 over 1, which is the denominator, right? So we're just looking at this first one right now. When I'm multiplying the whole thing, what property am I actually doing? Distributive property. So you are multiplying 1/2 x by 2 over 1, then you're going to multiply 3 over 2y by 2 over 1, and then you're going to multiply 5 by 2 over 1. So let's do this one first. If I have 2 over 1 times 1/2 x, let's draw an arrow next to this, what happens with the 2's? They cross-reduce, right? So what would I be left with? 1x. When I multiply 3 over 2y by 2 over 1, what happens? The 2's cross-reduce again. So what am I left with? Plus 3y. Equals, 2 times 5 gives me 10. Doesn't this look nicer? Let's do the same thing to the second one. Yes, it does. So now in this one, my two denominators are what? 3. So I'm going to multiply the second equation by 3 over 1. So what I want you guys to do is try that on your own now. So just on your own, really quick, 30 seconds, distribute 3 over 1 into the entire thing, and write down what your new equation would come out to. So if I were to distribute 3 over 1 into the parentheses, 3 over 1 times 2 over 3x, what would I be left with? 2x. Good. What about times negative 1/3 y, what would I be left with? Minus y. And 3 times 9 gives me 27. So what I want you guys to make sure, please do not forget to distribute to the equal sign on the other side, because whatever you do to one side, you have to do to the other. But a lot of times I see students doing everything correctly, and then they forget to distribute to the right-hand side. So just make sure that you don't forget that. Okay, so now we can use substitution to solve this system. So do you guys want to solve for x in the first equation or for y in the second? X in the first? So what would you do? Okay, so subtract 3y. And that gives you x equals negative 3y plus 10. Oops. So put parentheses around negative 3y plus 10. And all I want you to do right now, so it should take you like 10 seconds, substitute negative 3y plus 10 for x in the second equation. So just write it out on your own. So when you guys plugged it in, what would you get? Can somebody read me their equation? Brittany?
2
Mm-hmm.
times negative 3y plus 10 minus y equals 27.
Perfect. Thumbs up if you got this. So she got 2 times negative 3y plus 10 minus y equals 27. We don't write 2x because we plugged negative 3y plus 10 in for x, because it's equal to x on the other one. So here's what I want you guys to do now. Solve for y, and then take that y and solve for x for me. So you guys are going to do the whole problem now on your own. So, most of you got this, and then those of you that didn't, I was able to catch it right as soon as I walked around. What would you do first in solving for y? Distribute. So 2 times negative 3y gives me negative 6y, and 2 times 10 gives me positive 20, and then we have minus y equals 27. And then I saw a couple different things. I saw some people moving things to the other side at this point, although I think it's easier if you combine like terms first. So negative 6y minus y, what does that give me, guys? Negative 7y plus 20 equals 27. And now what would I do? Subtract 20. I ran out of room. And that gives me negative 7y equals 7. And then what would I do? Divide by negative 7. So I get y equals negative 1. And then we take this y and we plug it back in. You can plug it into this equation, you can plug it into this equation, or you can plug it into this equation. It doesn't matter. You would get the same answer regardless. I always plug it into this one because we already have x by itself. So that's going to be x equals negative 3 times negative 1 plus 10. What's negative 3 times negative 1? Positive 3 plus 10. And what's 3 plus 10? 13. So to write my answer as an ordered pair, which one do I have to put first? 13, comma, negative 1. And that's your answer. Who got that right, just out of curiosity? Even just the first part, because then plugging in your answer at the end. So after you solve for y, you just plug it in to get x. Okay, so example 6, we have 0.4x plus 0.3y equals 1, and 0.1y equals 0.2x. I hate that we have decimals in here. Yeah. I know, I don't like decimals. I actually prefer fractions to decimals. So let's take a look at this. Does anybody have any ideas of how I could change my decimals into whole numbers? I can make into a fraction and then do what we just did in the previous problem, but that's 2 steps. I can take away these decimals in 1 step. Jonathan, can you say it louder? Yeah, what if I just move the decimal over? That means I also have to do it on this side too, right? That's the same as multiplying by what? 10. In this case, it's 10 because we're only moving the decimal once. So since I moved the decimal over once here, make sure you remember to move it once on the right. I would get a new equation of, thank you, Anthony, 4x plus 3y equals 10. So what would I multiply the second equation by?
10.
Also 10, because I only want to move the decimal once. So what would my second new equation be? 1y, or y, equals 2x. I know. So now, what would I substitute?
Y.
I would substitute y, and what would I plug in for y? 2x. So do that. So that's, I'll start it for you. That's going to give you 4x plus 3 times 2y equals 10. Sorry guys, it should be 2x, not 2y. Okay, so that would give me 4x plus what, guys? 6x equals 10, and 4x plus 6x gives me 10x equals 10. Divide by 10, so x equals what? 1. Now, how do I solve for y? Plug it in, and how many of you plugged it into that one? Y equals 2x. That's the easier one to do. So this is y equals 2 times 1, so y equals what? 2, and what was your ordered pair? 1, comma too. Make sure that you are remembering, and even sometimes the high schoolers have trouble remembering this, so if you guys could get it, it would be amazing. That whenever you write an ordered pair that you put parentheses around it, because the parentheses tell me as a reader that these two numbers go together, and that the first one is always X and that the second one is always Y. So if you ever have X and Y in your equations, write your answer as an ordered pair so that I know they go together. Does that make sense? Okay, we have 2 definitions and 2 more examples, and then we're done. So I have to define for you a consistent and inconsistent system. A consistent system is a system that has one or many solutions. Many solutions could also mean infinitely many solutions, as in you could plug in any X and any Y and it would always work. Okay? So a consistent system has either one solution, like everything that we've seen so far. Every single one of those has one solution, one X and one Y. But you could also have what's called many or infinitely many solutions. If you want to write infinitely many, you can use the infinity symbol, which is a sideways 8. Okay? So a consistent system is a system that has one solution, which is everything that we've done so far. All of the previous examples, 1 through 6, have one solution. Or they could have more than one, or what we call many solutions. And typically, if it has more than one solution, it would have infinitely many solutions. And you use the infinity symbol. Write down example 7, and I'll show you what I mean by infinitely many solutions. Okay, so example 7, we have 3y equals 6x plus 3, and 12x plus 6 equals 6y. I think it would be easier to solve for y in the first equation, right? What would we have to do to solve for y? Divide everything by 3. So divide every single thing by 3. And that's going to give me y equals 2x plus, what's 3 divided by 3? 1. So remember when we were doing slope-intercept form, y equals mx plus b, and we were putting it in this form, you had to divide every single term by 3. So now we're going to plug in 2x plus 1 for y into the second equation. So that's going to give me 12x plus 6 equals 6 times 2x plus 1. Look at the left-hand side. Is there anything for me to do right now? Like multiply or combine like terms? What about on the right-hand side? Distribute. So distribute. So that's 12x plus 6 equals 6 times 2x is 12x, and 6 times 1 is 6. Oh my gosh. What do you think is going to happen?
It's going to be 1.
It's going to be 1?
No.
Look.
No.
If I subtract 12x from both sides, these 12x's cancel, and these 12x's cancel, right? And then, so that would be 6 equals 6, but I still need to subtract 6 from both sides, so we get 0 equals 0. Is that a true statement? Does 0 equal 0? Yeah. So we would say that this system has infinitely many solutions. It is a consistent system. What this is saying, so this would be your answer, infinitely many solutions. Anytime you end up where either everything cancels out or you end up with a true statement, like we could have stopped at 6 equals 6 because that's a true statement, it's always true. Anytime that you end up with a true statement or where everything cancels out, it's infinitely many solutions, because what it's saying, I can plug in any x that I want and it will always work no matter what. I can plug in any y that I want and it will always work no matter what. if we were to graph these two lines, they actually come out to the exact same line. Okay? So the two lines are touching each other, so there's infinitely many solutions. So what does it look like if there is no solution? We call that an inconsistent system. So inconsistent systems are systems with no solution. And I'll show you what that looks like in example 8. So write down example 8 and the definition, and then we'll be done. Okay, so I have 6x plus 3y equals 5, and y equals negative 2x plus 1. This is already pretty much set up for us, so I'm going to take negative 2x plus 1 and substitute it for y in the previous problem. So that's going to give me 6x plus 3 times negative 2x plus 1 equals 5. Yes? Are you guys comfortable with this? So what would we do next? Ideas? Distribute. So distribute's a positive 3. I always circle it so I remember the sign. So that gives me 6x. Positive 3 times negative 2x. What's that going to give me? Negative 6x. And positive 3 times positive 1? Positive 3 equals 5. My next step is always to combine like terms. So I have 6x minus 6x. What does that give you? 0x. So they cancel, right? So we would end up with 3 equals 5. Is that true?
No.
No, definitely not true. So we say that this has no solution. The symbol for no solution is a circle with a line through it. Okay, so you could also give me just a circle with the line through it. That's fine. So, moral of the story. Anytime everything cancels or you end up with a totally true statement like 0 equals 0, you have infinitely many solutions. Anytime everything cancels and you end up with a false statement like 3 equals 5 is no solution. All of the other problems that we have done today and yesterday, where you write your answer as an ordered pair, that's one single solution. Does that make sense? Okay? So that is solving by substitution. That is your homework tonight, numbers 13 through 18 all. So you have a whopping 5 problems. I know. And we'll learn a new method on Thursday.